Okay, so we've got f at x, and we want to show the derivative. All right, so we have quotient rule. So this is 2 to the x squared, and then we start with 2 to the x times the derivative of u minus u times the derivative of v, which is 2 to the x natural log 2, and we can factor out a 2 to the x, so that's going to be 2x minus x squared natural log 2 on top, and then 2 to the x, and I'll just do it like this. So we have what they wanted us to show. So AI double I, obtain expression for the second derivative. So we have 2 to the x squared and 2 to the x times the derivative of u, which is 2 minus 2x natural log 2 minus, the derivative of v, which is 2 to the x natural log 2 times 2x minus x squared natural log 2. All right, so then we have, we have a 2 to the x here. So we're going to have 2 minus 2x natural log 2, and then minus 2x natural log 2, because this is gone and distributing the natural log 2, the minus natural log 2. And then we've got plus x squared natural log 2 squared over 2 to the x, 2 to the x. And finally, that's 2 minus 4x natural log 2 plus x squared natural log 2 squared over 2 to the x. All right, for b, we want to find the exact value of x satisfying the equation first derivative equal to 0. So we have this equals 0, cross multiply by 2 to the x. We're going to have 2x minus x squared natural log 2 equals 0. Factor out an x. We're going to have 2 minus x natural log 2 equals 0. So x is 0, which it can't be. And 2 minus x, so we can do like this. So 2 over natural log 2 is the value of x satisfying that equation. Show that this gives a maximum value, so we would substitute that into the second derivative. So we're going to have 2 minus 4 times 2 over natural log 2 plus 2 over natural log 2 squared times natural log 2 squared over 2 to the 2 over natural log 2. Okay, so canceling some things, this and this, because of that, and this will cancel. So we're going to have 2 minus 8 plus 4 over 2 to the 2 natural log 2. This is negative 6, negative 2 over 2 to the 2 over natural log 2, which is less than 0. So it's concave down. It's a maximum at x equals 2 over natural log 2. Right, C, find the x-coordinates of the 2 points of inflection. So we would set second derivative down here equals 0, multiply by 2 to the x. So we have 2 minus 4x natural log 2 plus x squared natural log 2 squared equals 0. So this we can solve for x because it's quadratic, where a is this, b is this, and this is c. So we're going to have x equals negative b, which is already negative, so 4 natural log 2, plus or minus the square root of b squared minus 4ac all over 2a. Then we have 16 natural log 2 squared minus 8 natural log 2 squared over 2 natural log 2 squared. Okay, so this ends up being 4 natural log 2 plus or minus root 8 natural log 2 squared over 2 natural log 2 squared. And then this comes out 8 because this is 4 times 2. So we're going to have 2, and then this obviously is just natural log 2 coming out. The square root of 2 stays in. 2 natural log 2 squared. Okay, so now from this, we can factor out a 2 natural log 2. So on the inside, we're going to have 2 plus or minus root 2 over 2 natural log 2 natural log 2. Those cancel. So we should have 2 plus or minus root 2 over natural log 2 for the x coordinates of the 2 points of inflection. They tell us it's a point of inflection, so we don't have to check it. All right, we've got a family of cubic functions defined like this, expressed in terms of k, the derivative. Okay, so we're going to have 3k squared x squared minus 2kx plus 1. Second derivative is going to be 6k squared x minus 2k. Now the coordinates of the points of inflection, so we set this equal to 0. We have to do it in terms of k. So this is 1 over 3k. That's the coordinates of the points of inflection. So we need to just substitute that back into the original function. So k squared 1 over 3k cubed minus k 1 over 3k squared plus 1 over 3k. So this is going to be k squared times 1 cubed over 3 cubed k cubed minus k times 1 squared over 3 squared k squared plus 1 over 3k. Okay, this k cancels all but one of those, so we have 1 over 27k. This one cancels one of those, like this. And now we just need 27k on the denominator. So we have 1 minus 3 plus 9, which is going to be 7 over 27k. So the point of inflection is 1 over 3k, 7 over 27k. So now it says show that all of the points of inflection, which it's just one, lie on a straight line and state its equation. So I think since they say it lies on a straight line, so we can use 2 points. Like we can sub in k is 1 and maybe k is -1, just to keep it simple. So we are going to have for k is 1, 1 over 3, 1 over 27. 7 over 27, sorry. And then for negative 1 over 3, negative 7 over 27. So then we have y2, y2 minus y1 over x2 minus x1, which is going to be 14 over 27 divided by 2 over 3, which is 14 over 27 times 3 over 2. Those cancel to be 7, and this cancels to be 9. So so that's the gradient. So if we used one of these points, y minus 7 over 27 equals m, x minus 1 over 3, and then we had 7 over 9x minus 7 over 27 plus 7 over 27. So we've got y equals 7 over 9x. All right, so show that for all values of k, the tangents to the graph of f of k on p sub k are parallel. So if we find the tangents to the graphs, okay, so we need the first derivative at 1 over 3k, which is going to be 3k squared 1 over 3k squared minus 2k 1 over 3k plus 1. So 3k squared times 1 over 9k squared minus 2 over 3, because the k's cancel, plus 1. So this is going to be 3 over 9, 1/3, minus 2/3 plus 3/3, 1. So that's going to be 2/3. So we've got, for whatever k is, because I put k in there, the tangents of the graphs are all 2/3. Okay, so that's the graph. So we need to see what the function is at 1 over 3k. So that's going to be k squared. Did I already do this? Yes, I already did this. It's 7 over 27k. So we are going to have y minus 7 over 27k equals m x minus 1 over 3k. So 2/3 x minus 2 over 9k plus 7 over 27k. So 2/3 x, and then this is times 3. So 1 over 27k. All right, a curve has the equation that show second derivative. Okay, so first derivative, if we rewrite it like this, this is just the function. So the first derivative is going to be negative a b plus e to the negative c x to the negative 2 times the derivative of the inside, which is just e to the negative c x times again the derivative of the inside, which is negative c. So if we make that look a bit nicer, that's going to be positive ac e to the negative cx over b plus e to the negative cx squared. Second derivative, quotient rule. So b plus e to the negative cx squared squared is fourth, and b plus e to the negative cx squared. So v times the derivative of u, which is a c e to the negative cx times negative c, minus u times the derivative of v, which is 2b plus e to the negative cx to the 1 times e to the negative cx times negative c. What a mess. So now, b plus e to the negative cx to the 4, and we have one of those can be taken out because we've got to the third on the bottom. So this is, and this is. So we're going to have b plus e to the negative cx. And what else is in, well, I'll just deal with that in a second. All right, so we need another one of those. And then we need, it's going to be a negative here. And then we're going to have ac squared e to the negative cx. Then we're subtracting, adding, because of this and this. So 2ac squared e, and then we've got this and this, which are, we're adding, so it's negative 2cx. Okay, so this cancels with one of those. And now we have an a, we have a c squared, we have 1 e to the negative cx, just one of those. Okay, and now on the inside, we're going to have a 2, I'm just doing this one first, another e to the negative cx from this, minus, because of this, b plus e to the negative cx, all over b plus e to the negative cx cubed. And I think it almost looks like that, right? So we have a c squared e to the negative cx, bracket. Okay, so now we're almost there. So we have 2e to the negative cx minus e to the negative cx here. So that's where they get just 1e to the negative cx minus b over this. Okay, so find the coordinates of the point on the curve where the second derivative is equal to 0. So this equals 0, denominator goes away. A c squared e to the negative cx, e to the negative cx minus b equals 0. So here, this will never equal 0, but we can have e to the negative cx minus b equals 0. So this is b, writing it natural log equals negative cx. So x is natural log b divided by, so 1 like this. Okay, so negative 1 over c natural log b. They would say the coordinate, so we need back into the regular function, negative 1 over c natural log b. So a over b plus e to the negative cx, which is negative 1 over c natural log b those cancel, and plus, and e to the natural log b is just b. So it should be a over 2b. So that's the coordinates, negative 1 over c, natural log b, a over 2b. Now, if we want to show that this is a point of inflection, if you look back over here at the second derivative, if this is a point of inflection at that x, our second derivative needs to change sign, okay? So it needs to change from negative to positive or positive to negative on either side of negative 1 over c natural log b. So if we look up here, we have a is not 0, b is greater than 0, c is greater than 0. Okay, so this could be negative or positive, all right? This is positive, this is positive. This is positive, this is positive, a positive cube, that whole thing is positive. So, basically, A could be positive or negative. So if we just show that this in here changes on either side of negative 1 over c natural log b, then we know that the second derivative changes signs. Maybe listen to that again if you didn't catch that. But, okay, so we have this here is what we're interested in. Okay, so we know at that point, at that x, it's equal to 0. Okay, so what I've written, this is on the left side because we're subtracting 1, and this one's on the right side because we're adding 1. So, yeah, if we distribute the negative c, we're going to have natural log b plus c minus b. We can separate these. And e to the natural log b is b, e to the c minus b. And then if we factor out b, we have e to the c minus 1. On the other side here, we're going to have e to the c, that's a b supposed to be there, natural log b minus c, then minus b, separating, oh, this is not c rather, sorry. The c's cancel. So separate them like this. This is b over e to the c minus b. And factoring out of b, we're going to have 1 over e to the c minus 1. So b is a positive number. That's what that said up there. So we are just concerned with this. So if you don't know, c is just a positive number. So it could be a fraction. So if it's like 1/2, and it could be over 1. So let's say 2. So in this case, e to the 1/2 minus 1. And this is 1 over e to the 1/2 minus 1. So in this case, this one's equal to about 0.6487. And this one is equal to negative 0.393. So in both of these cases, the signs change. And if c is 2, we have e to the 2 minus 1, which is 6.39, and 1 over e to the 2 minus 1, which is negative 0.865. Either way, signs change. This is a point of inflection.